today we will talk about Ohm's law. So this scientist, Ohm, discovered that relationship experimentally, and the relationship was among three quantities: I, electric current, and the unit is ampere or amps, V, potential difference, or voltage, and unit is volt, capital V, and one more quantity, R, resistance. Symbol is R. So what is resistance? Any electrical device, any, will try to prevent electrons to flow through this device. So it's like opposition to flow of electrons. And unit was named after Ohm. Resistance measured in ohms. Or we also can use Greek letter omega. So I'll give you two examples. Let's say resistance equals 5 omega or ohms, and the second one, resistance equals 25 omega. It could be more or less the number. So through which one it would be more difficult for electrons to flow? Obviously through the higher number. So there's more opposition to flow of electrons in this resistance, 25 ohm, or if you compare it to 5 ohm, whereas flow of charges would be easier. Okay, so if resistance is high, right, when resistance is high, flow of electrons is low. Okay, so that relationship was discovered between among these three quantities by Ohm experimentally. So to do that, we can look at very simple electric circuit. We never did electric circuits before, so I'm making a very simple one. So I'm putting in the circuit lamp. Okay, that's the symbol for lamp. And obviously we need the source of potential difference. It could be a cell or battery. I'm putting battery. We discussed the symbols yesterday. And if I want to measure number of electrons which flow through the circuit per unit of time, I can place the device that measures flow of charges or current. It's called ammeter. So all the electrons will flow through lamp and then through the ammeter as well. That's how it counts number of electrons that flow per unit of time. So I will show you the difference between cell and battery. So that would be example of one cell. It's double A battery, we call it, right? It's one single cell. We can use 2 or 3 of them, right? Potential difference will be increased if you use more. But what each cell has, it has positive terminal, right? And negative terminal. And here on the diagram, they use short parallel lines and long. So the short one will represent negative sign or negative terminal, and long one, positive terminal. So as you remember, electrons are negative charges, right? And these are connecting wires, which have they're made of metal, usually copper, and they have a lot of free electrons. So once you connect everything in one complete circuit, or we call it closed circuit, electrons start moving here, and they will repel from negative terminal and will be attracted to positive. So that means negatively charged electrons will flow in clockwise direction in this circuit. Okay. So Ohm had some similar diagram, and he was changing potential difference, and he was changing the resistance. So you can use different lamp with different wire inside, okay? So you can change resistance and you can change potential difference. And he was measuring electric current and tried to find out what is the relationship. Okay, and what he found out, actually two very important things. So Ohm found out, number one, as potential difference increases. For example, you can place first just 1.5 volt cell, and then, for example, 2 or 3 voltage will increase, right? So that means electrical energy in the circuit will increase as well. So, and you can predict that electrical current I will increase as well. So when potential energy potential difference increases, electrical energy in the circuit increases, and that makes more electrons flow faster, right? And it increases I. So how do we call that relationship? When one quantity increases, the second increases as well. Direct proportional. And if you decrease voltage in opposite, electrical current will decrease as well. So it's direct relationship. And then he tried to change the resistance. So as resistance, for example, increases. Remember my examples? Resistance can be 5 omega, 25 omega, 50, 100. So as resistance increases, that means it becomes more difficult for electrons to flow through this resistance. So obviously, if it's more difficult for electrons to flow, electrical current will decrease. Okay? So what do you call that relationship? When one quantity increases, the other drops, it's called inverse proportional. And an opposite, if you decrease resistance, so it's much easier for electrons to flow now, and current will increase. So analyzing this type of changes in the circuit, Ohm wrote down the equation that electrical current directly proportional to V, right? Directly proportional, that's why V is on the top, and inversely proportional to resistance. Okay, I can solve that equation for V, and V will be equal IR, right? IR. Or I can solve that equation for the third quantity, for R, by dividing both sides by I. And resistance will be equal V over I. Okay. This last way for this equation, last form of this equation, is in your reference table in electricity box. So these equations are called Ohm's law. Okay. And when you look at them in any form, it's very difficult to understand what depends on what. So it's very important to understand. Number one, I, or electric current, depends on V, potential difference, direct proportional. Okay. Now look over here. If I'm increasing V, I increases, right? I can show that in all of them. As V increases, I increases. Direct relationship. So when you increase potential difference, you're increasing energy, potential electric energy. Obviously, it will produce a higher current. But what you should keep in mind, if you're changing I, if you want to change I, you change V. R is supposed to be kept constant. As in any science experiment, when you're performing, you cannot change more than one quantity. So you keep resistance constant, right? You're changing potential difference. If you increase it, current increases, and all the way around. And number two, electrical current depends on R, on resistance, not all the way around. Resistance does not depend on I, like V does not depend on I. Remember that V is printed on the battery or power supply. You know what amount of potential difference you have. So it's like fixed amount. The same thing with resistance. It's also printed on electrical device, 5 ohm or 10 ohm or 100 ohm. Let's look at this equation. Let's say I'm increasing R. Like I told you, you cannot change both quantities at the same time. So you're only changing R, and you keep a V fixed, it's constant. So if you're increasing R and V is constant, what must happen to I? If it's inverse relationship, it will drop. Okay, so it's very important to remember that electrical current depends on V and electrical current depends on R, not all the way around. And one more thing I want to mention at the end. R is resistance. Okay, it shows how the device opposes to the flow of charges, flow of electrons when they pass through this resistance. It's a scalar quantity, doesn't have any direction. Okay, and the unit is ohm or Greek letter omega. Okay, so tomorrow we will discuss what can we do to change the resistance. Okay, what resistance depends on, and we will discuss that tomorrow.